Welcome again to another one of my sessions. In this tutorial, we will be looking at the topic of matrices. Matrices is the plural of the word matrix. Now, what is a matrix? A matrix is an array of numbers arranged in rows and columns. An example of a matrix is shown here. Notice that these numbers are arranged in rows and columns. Now, if I draw lines to separate my rows and my columns, I will notice that there are no cells that are left blank. A matrix must have all of the cells being occupied. So here I have 4 by 4, that's 16 cells. So 16 cells and all being occupied. So that is one of the features that a matrix must satisfy. Now, when I say cells, I'm referring to each one of these. So you are seeing that there are 16 cells, right? So I cannot have an arrangement of numbers, for example, this here, and call it a matrix. It will not be a matrix, simply because if I decide to divide up my rows and columns, I am going to notice that there are indeed blank cells. All of these cells here are blank, and as such I cannot call this arrangement a matrix. This is not a matrix. Now, each value that is in a matrix is called an element. So just as there are 16 cells in this matrix, there are 16 elements. Now, each element of a matrix is strategically put into a different cell, and it must maintain the order in which these numbers appear. So for example, if I have another matrix, let's say I have the matrix, let's say I have this matrix here. This is not going to be the same as the matrix this. These two matrices here are two different matrices, simply because the arrangement of each one of the elements are different. So let's now learn about the different positions that each one of these elements here occupy. So I'm looking at our first element, 2. This 2 is in the first row and our first column. So this cell is the first row, first column. I'm using R to denote row and C to denote column. Our 3 is in our first row, second column. So first row, second column. Now, keep in mind that rows run horizontally. These are rows, and columns run vertically. So these are columns. An easy way to remember that is, think about when you are building a wall. Those pillars that they use in the walls are called columns, right? And they are constructed vertically. So that's an easy way to remember how columns run. They run vertically. And obviously, when you remember that, you are going to remember how rows run. So let's continue. 7 is in our first row, third column. Our 1 here, first row, fourth column. Our 4, second row, first column. Our 0, second row, second column. Our 1, second row, third column. Our 5, second row, fourth column. Our 1 here, third row, first column, etc. Right? So now you are able to identify the different positions that the elements occupy. Now, sometimes a matrix may be identified based on the order of the matrix. So, for example, I have this matrix here, and I am going to determine the order of this matrix or the size of the matrix. Now, whenever you hear order or size of a matrix, it is referring to the number of rows as well as columns of the matrix, and it is written in a particular way. So, the order or size of this matrix is the number of rows by the number of columns. So if I look at this matrix, I'm going to see that there are 4 rows as well as 4 columns. So I'm going to write the order as 4 by 4. Now you are not going to evaluate this. This is just the way in which you write it. It's the format in which you write the order of a matrix. So when you are asked what is the order of this matrix, you are going to say it's a 4 by 4 matrix. Let's look at some other matrices and determine the order or size of them. So here you have 5 matrices, and you would notice that the arrangement of numbers is enclosed in a bracket for each one of the matrices, and that is how a matrix is usually presented. So the arrangement of numbers is enclosed in brackets, whether it be a curved bracket or a square bracket. So we are going to determine the order or size of each one of these matrices. Remember, the order of a matrix is written as the number of rows times the number of columns. So here you are seeing that we have 2 rows. So that's 2 by, how many columns do we have here? 1 column. So this here is a 2 by 1 matrix. Here now, the second one, you have 1 row and 2 columns. So the order of this matrix is a 1 by 2. Next, we have 1, 2 rows and 3 columns. 1, 2, 3. So this here is a 2 by 3 matrix. Next, we have 1, 2, 3 rows by 1, 2, 3 columns. So it's a 3 by 3 matrix. Next, we simply have only 1 row as well as 1 column. So this matrix is a 1 by 1 matrix. Now, any matrix that has only 1 column is called a column matrix. And we can see that our first matrix here is a column matrix because there's only 1 column. Any matrix that has 1 row is called a row matrix. Any matrix that has the same number of rows as columns is called a square matrix. And we can see that here we have 3 columns as well as 3 rows. Now, this matrix and this matrix doesn't have a particular name, right? Just as this has the name column matrix, this one is a row matrix, and this one is a square matrix. This doesn't have a particular name. Now, one more type of matrix to note is equal matrices, right? Now, two matrices are said to be equal if their corresponding elements are equal, right? So this matrix here is going to be equal to this matrix here simply because their corresponding elements are equal. And that there is a basic introduction to the topic of matrices.
Don't forget to like, share and subscribe for more of my videos.